Hello, I'm Jessica, a third-year graduate student in the laboratory of Dr. Neha Garg at the Georgia Institute of Technology. Our lab uses mass spectrometry to characterize the metabolomic profiles of microbial communities, including the coral holobiome. In non-targeted metabolomics experiments, one can annotate about 1 to 10% of detected metabolites. To enhance our ability to decode the dark metabolome, we use a variety of in silico tools to aid our annotation efforts. Today, I will show you how to use the GNPS LCMS dashboard to generate XIC on chemical formulas suggested by the in silico tool Sirius with CSI Finger ID. The LCMS dashboard analysis allows us to rapidly visualize multiple XICs, as well as search for potential adducts, such as M plus sodium and N plus potassium, which can further validate proposed chemical formulas. This video is part of the use cases for the GNPS dashboard paper. Sirius with CSI Finger ID allows the user to upload a mass list for MS1 and MS2 spectra. The user can choose from a variety of parameters, including which instrument data was acquired on, as well as which databases to consider chemical formulas from, and which databases to consider potential compound annotations. The output includes proposed chemical formulas and putative compound annotations. The particular file that I am interrogating is MSMS data acquired from organic extracts of a bacterium isolated from coral tissue by our collaborator, Dr. Valerie Paul. Sirius proposes the chemical formula of C25, H39, NO5 as the most likely for this mass to charge of 434.29. We'll take this chemical formula and go to the LCMS dashboard. Here I have already uploaded the file which I wish to look for this chemical formula. I've put the chemical formula C25, H39, NO5 under XIC formula, and I have chosen the tolerance for the precursor mass. Notice how I have chosen the neutral mass for this XIC formula. The only other change I've made is under XIC grouping, where I have chosen to group by file. The output from the dashboard shows traces for the M plus H, M plus sodium, and M plus potassium adducts. And I'm particularly interested in the feature including at this retention time, and we can see that the possible adducts are M plus H and M plus sodium from the blue and red traces. Oops. To zoom back in, I will do as such, and we can also see that M plus potassium is not detected at this retention time. So this confirms that this particular adduct is not detected. We can also use LCMS dashboard to perform an XIC on multiple files, which I have uploaded. These include analytical standards of coromycin, which was one of the top proposed compounds when we filtered for biological hits in Sirius. And I've also uploaded files of bacterial extracts from Dr. Paul. I have searched for the master charge for coromycin A. I have adjusted my tolerances for the precursor ion, and I am grouping by master charge. My output shows me that coromycin A is detected in the standards, as well as in one of the bacterial isolates. This suggests that this isolated bacteria is different from the other isolates. I also noticed at 11 minutes another feature eluting, which corresponds to an isomer, later confirmed by MS2 annotation, to this feature at 13 minutes. And so the isomer at 11 minutes is present in lower relative abundance, suggesting that conversion between isomers occurs during purification. This example has shown how to use the LCMS dashboard to generate an XIC on a chemical formula. Additionally, we compared XIC of multiple files, including analytical standards and bacterial isolates. I hope this use case will aid you in your data analysis.